All right, welcome everyone. So let's go ahead and try and apply this bisection function bisect that we created in the previous video to try and track down and find some roots of the function f of x is equal to x minus 3 times x plus 1. So we can very easily see this is a factored quadratic that the zeros are x equals 3 and x equals minus 1. But the point here is, let's suppose we didn't know where those were. How could we track them down? So in the previous video, we talked about what the bisection method is and how we could set up a formula bisect that is going to find a zero of some function that we define fun. So we're going to apply that in this video. So if you have no idea where this code came from, I would encourage you to watch the previous video to see what's going on in that code cell. So over here, I'm going to define this function f as a function. So I'm going to assign this function f as a function of x, and it's just going to be x minus 3 times x plus 1. So now we've identified this, and it's a function. So given different values of x, we get different outputs of f. I'm going to run this code cell. And I'm going to plot this function in the xy plane. So this, how I'm doing that is, this is picking off a vector that has a bunch of values, 1,000 equally spaced values between -2 and 4. So you can imagine like 1,000 values marked on this x-axis. And now what I'm going to do for each of the 1,000 values in this vector x-vals, we're going to evaluate the function f at that point. So now we've got 1,000 points that we've plotted, and we're going to join all of those points with a line. That's what L means. We could just leave them as points, and I don't know, I think that's a P. Oh, no, that was a thick line. But in any case, I want a thin line, so it's going to look like this. Okay, so now we've got all of our, this is the function, and we can identify that there is indeed 1, 0 at -1 and 1, 0 at 3. But let's see how we can use this bisect method to identify the zero that's located between 2 and 5. So that's this one right here. So this function that we created previously, we're going to set lower equal to 2. We're going to set upper equal to 5. We're going to set our function equal to this function f that we defined. And I'm going to leave the epsilon value as the default. I'm sorry, I never ran this code cell. Here, I've run this bisect code cell. So now we've defined this function that implements that bisection method. And now this is telling me that the zero between 2 and 5 is at 2.99998. So it's an approximation method. We exited once we got within a certain level of accuracy of the actual zero, which occurs precisely at x equals 3. So I didn't get x equals 3 here because we found the value that was close enough to 3 that our while loop exited. And if I want to track down the 0 at -1, I would need to plug in an x value on each side of that. So here I could pick -2 and 1. I can run this, and this is also giving me a good approximation for the actual 0, which is at -1. If I chose values -4 and -5, they're like over here. There is no 0 of f between -4. Oh, I'm sorry. I said -4 and 5. So -4 is like way over here. 5 is way over here. We actually have a set of 2 zeros that are between them. But more importantly, what's going to happen, f of -4 is a large positive value. F of 5 is a large positive value. So the function f has the same sign when I evaluate it at these endpoints. So we're not even certain that there's a zero in between them. And that's what happens over here. So this is saying there was an error. And this is the error message that I customized over here. So this is saying, we got bad starting values. You need to choose starting values so that one of them is positive and one of them is negative. Okay, so we'll stop here. And in the next video, you'll have a chance to apply this bisection method to try and approximate the value of pi.